Hi, my name is Nick Nesselrode, and I'll be walking you through my graphic novel on the genus Streptococcus. So I'll start with a picture of the whole page and then kind of zoom in from there. Streptococcus is a gram-positive bacteria. They are catalase negative, non-motile, non-spore forming. They reproduce via binary fission. They belong to the phylum Firmicutes. There are more than 50 species of Streptococci, and they are facultative anaerobes, most, although some are obligate anaerobes. Some common illnesses that are caused by Streptococcus would be scarlet fever, strep throat, pneumonia, some neonatal infections, which we'll talk about later, and even UTIs. Some of the pathogenic species are classified into groups, and these are based on some classifications done by Rebecca Lansfield, and they're based on their hemolysis and the antigens that are produced by each of the different species. So they can be classified into A, B, C, G, and there's more. This is the cell wall of our gram-positive Streptococcus. So in the middle, you've got the cytoplasm, then the phospholipid bilayer, then a thick peptidoglycan layer of those NAG and NAMs and the cross bridges between. Then you've got some lipoteichoic acids that go through it and some pili that can come off of it. Group A Streptococcus have something called M proteins that aid in attachment and a hyaluronic acid capsule that actually keeps it from being phagocytized by other parts of our immune system. And so this helps it to be more virulent. So you can see Streptococcus divide by binary fission, and they are circular. So you can see in the first image that it is a single strand of DNA. Then the DNA replicates and goes to opposite ends, and it starts pulling apart in that divide in the middle. Then it finally splits into two, and oftentimes the streptococci just stay connected together. And in some different species, they're diplococci, and so they'll just stay two of them stuck together. And then others are forming long chains, which we know of as the, kind of classic Streptococcus. We'll go through a couple of species here that are likely most notable. So group A, Streptococcus pyogenes. So this one is the cause of necrotizing fasciitis, impetigo, strep throat, scarlet fever, pharyngitis, and can often cause toxic shock. They are hemolytic, which means that they often grow when they're cultured on blood agar plates. And you can see there on that slide that the yellow is where the bacteria is growing and it has eaten up all of the blood agar around it. Next up is group B, Streptococcus agalactiae. These are typically diplococci, so you'll just see them in those groups of two. This species is the most risk for neonatal infection, UTI, sepsis. So a birthing person may not have any signs or symptoms that they have group B strep, but it can be really dangerous for an infant during birth. And so GBS screenings typically start in the 36th week of pregnancy. And if the birthing person does have group B strep, they're usually given antibiotics about 4 hours before the baby is born. Next is Streptococcus pneumoniae. This species is very resistant to many antibiotics. It's also diplococci. It has an antigen capsule of polysaccharides around it that typically repel a gram stain and is pretty noticeable when you are growing and culturing it. And this species causes pneumonia, respiratory, and ear infections. For pathogenic species of Streptococcus, penicillin is usually most effective. Erythromycin can be given to people who are allergic to penicillin. It's usually a 10-day round of antibiotics, and you want to make sure and take the full 10 days. The ones that stick around the longest are typically the most resilient, so you want to make sure you kill all of those bacteria so they don't come back stronger later or develop into something more harmful. Streptococcus gets a bad rap, but I wanted to end on a good note. So Streptococcus thermophilus, produces formic acid, ferments lactose. It has a positive influence on our gastrointestinal health and is part of a lot of starter cultures. It's non-pathogenic and used in yogurt and cheese production. So typically we think of Streptococcus as being pathogenic, but there are plenty of species of Streptococcus that are non-pathogenic. Thank you so much.